to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello and welcome to another meeting of the C++ Digital Signal Processing, JUCE, and plenty of other things study group. How are you all doing?
Yeah, cool. Doing fine.
I like that plenty of other things.
It is mostly tangents at this point.
Yeah. But it's still fun.
That's the most fun for me. So,
I need to get started with C++.
tell me more about it. What did you work on these couple weeks, Bo?
2 failed projects.
Failed projects? Oh no.
Failed?
One sort of just stopped. I just stopped working on it, and the other one I cannot get the code to work. But we can talk about that. What's on your plates?
Well, do you want to share why you decided to stop that project and what problems you are running into the other project? I suppose it's in your day job, not in anything related to digital signal processing, right?
No, it's actually digital signal, DSP. So I got some code to show you. If you wanted to, should I start?
Yeah.
Okay.
You already did.
Yeah, I suppose so. Let's share my screen. Generic, start sharing. So first, the thing that I just quit because I got a headache, I was going to do an all-pass filter. And the idea is to make a widener from an all-pass filter.
That's the Dan Warrow idea?
No, actually no. It's quite similar to it. But it takes a mono. So Dan Wardle's idea was to make a phase shift and then separate the mid and the side from a stereo signal, right? Wasn't it?
I think it was to do the all pass on the side only.
Yeah, only either or. So only the mono or the side. So you phase shifted one of them in order to create a separation. And it was a highly specialized tool. I haven't found much use for it, unfortunately. But this idea, it's kind of using the phase shift thingy, but from a create a phase shift in a mono signal via an all-pass filter, and then adding it to one channel, that phase shifted signal minus the original signal, so you only get the phase shift. Adding that to either the left and then subtracting it from the right, so you get a difference between the left and the right. If you catch my drift.
I remember this idea. We talked about it. How, at least in the way that you had it, one like the left would be the opposite of the right. It would be
Yeah.
Polarity inverted.
Yes.
I remember that.
All right. So I got this far with the alt pass. Then I got a headache. And I stopped.
Okay.
I never used the RBJ myself, the RBJ calculations, but I was thinking of using a library, but I decided to do it the hard way.
Of course.
Because that's the way I do. That's the way I roll.
All right.
So this is how far I've gotten with it.
And do you want to try and continue it here now?
Yeah, we could do that, I guess.
Okay. So I see that in the init section you have this sine hyperbolic. It's probably something you have already tested. I'm going to trust that that's right. So the sliders are the cutoff frequency, the Q, and the amount. And I guess the amount is kind of a dry wet knob.
Yes, exactly.
Okay. So let's focus on the frequency and Q. You're calling this slider 1 and slider 2. So let's look at the code that you have on the sample section. You are adding sample 0 and sample 1 to create a mono signal. I suppose that strictly speaking, you should multiply by half or divide by 2, however you want to think about this, because if both the left and the right channels are very loud, you don't want this to clip, right?
I'm thinking like this. If it's summed and I create a phase difference and then I subtract the original signal, it's going to be low anyway.
Oh, okay.
So that's my thinking.
Fair enough. Let's go with that. And then you have this section that I recognize because it's something that we have implemented before. It is the formulas to compute the coefficients for the filter. And strictly speaking, it's okay for this to be in the sample section, but it's wasteful because these coefficients only change if you change the sliders. You don't need to recompute them on every sample. So you could put this in the slider section if you wanted. It would be faster for you to do that. I mean, the plugin would consume less CPU to do that, if you do that.
Like this entire section?
Yes.
All right. Slider.
As a matter of convention, can you put the slider section below the init section? Usually the init section is the first.
Sure.
It doesn't matter because the execution is going to be the same, but for the sake of like readability, it makes sense to do it like this. Good. So now let's go over each line in the slider section and see what we are missing. For instance, there is a dB gain variable that is used there. That is not really necessary. That is not really defined anywhere.
No.
But also, it isn't necessary because dB gain is for things like shelves or bells.
All right.
As you can see, dB gain is being used to compute a variable called capital A.
Yep.
Capital A is only used in one place to compute beta, but beta is not used anywhere. So that would be necessary for shelves, bells, and so forth. But since you're dealing with a null pass, you can delete this line, and you can delete the line that defines capital A as well. Now, let's read the line for defining omega. It's using two variables, frequency and sample rate. Frequency is probably slider 1, right? So either you can, and I prefer that you assign slider 1 to a variable named frequency. Yeah, I like that. And I think you need a column there, if I remember correctly.
Yeah, so the first column.
No, it's not a column. I forget. I'm starting to forget JSFX syntax. Oh no.
Let's check into the plugin.
It's an equal sign.
Equal, yeah.
In my defense, it is kind of a weird syntax. It's not reminiscent of any other language. Well, it kind of looks like an assignment. Anyway.
But it isn't apology why you're forgetting syntax.
Why was that?
It couldn't be an apology why you're forgetting syntax.
Yeah, I'm getting out of touch. Anyway, so now the frequency variable is covered. The sample rate in JS effects is called S rate.
That's right. Yeah. Oops.
And you can tell that it's right because it changed color. Now for sim omega, that looks okay. It's only using omega. Same for cosine. And so now we can see that we are not using the sine hyperbolic. So that function is not being used. You might as well just remove it. Which means you might as well just remove the whole init section.
Oh. All right.
And then alpha is sine omega divided by 2 times q. And that means that we need to define a variable named q. And I guess that's going to be slider 2. So go to slider 2, column, capital Q equals. And with that, we can assume that we have coefficients, that they are set and that they work. So now let's go back to the sample section and use the coefficients to actually implement the filter. And perhaps it would be useful to look at the formula that we need to implement. So can you open the document again? I mean the RBJ cookbook?
It's specifically one that we want, isn't it? Because there's a bit of a mess. There's a lot of different versions.
I did some research, and I think that there are 2 versions that are different. I mean, there are thousands of versions you're going to find online, but most of them are just copy and paste. There are 2 different versions, and the one you want to use is the most commonly found. So you can click on any of those links, like the W3C link, and maybe not that one.
No, you got a point. That was an advertisement.
That is probably going to work. Yeah. So what we are looking at is equation 4, which is the direct form number 1. This is a formula. Do you see it? You scrolled up, so it's equation 4. It's right under your cursor.
All right.
And let's make sense of what these letters are. So you can see a bunch of A's and B's, like B0, A0, B1, A0. All of those A's and B's, they are the coefficients that we have just computed. But note how the B's are not used directly and the A's are not used directly. They are always divided by A0. We call this normalizing the coefficients. And B0 and A0 only change when you change a slider. So B0 over A0 is only going to change when you move a slider. So we might as well just do this division in the slider section before we even try to use this formula. So we don't keep doing the divisions over and over unnecessarily. Do you see what I mean?
Yeah, not using them in the sample section, right?
Yeah, we are going to be using them in the sample section, but we want to compute the divisions.
The B0 divided by A0.
Yes, we want to do that in the slider section.
All right.
To save some CPU. So let's go to the slider section and do this normalization.
Slider, yes.
It's going to be after you compute the A's and B's, because you're going to need to use the A's and B's. And the way that I usually do this is I just change the meaning of B0, and that's the way that most people do it, by the way. Just change the meaning of B0. So you say something like B0 divided equal A0.
Hang on. Why is my... Where's my keyboard going off again? Yeah, sorry, B0 divided.
Yeah, slash equals A0. And
No?
you need the equal sign. It's slash equal sign A0. So the
Oh,
point of this is
sorry.
that now B0 is equal to B0 divided by A0.
All right.
So it is normalized now. Do you see what's going on there?
Yeah.
Okay, so now rinse and repeat for B1, B2, A0, B1, B2, A1, A2.
Same thing.
Yeah, just perhaps
Wow.
copy and paste that line and change B0 to B1, B2, A1, A2.
Why is my keyboard effing up?
What's happening to it?
Oh, it's those. Hang on, I need to check. Oh, it's not that. It's not doing a return. What in the frig? Return to get one.
You're having to copy and paste.
Returns. Oh.
No, you don't want to change that A0. You want to change the B0.
No.
Refer back to the formulas and you see why I'm saying that.
Okay. And then B2 is no.
Yeah.
Oh, frick. Wait, it's that insert thingy. Oh man.
Ah.
Oh.
Is it your keyboard that is doing this, or is it the Reaper
Yeah.
IDE that is doing this?
No, it's a keyboard. What in the frag? And every time this happens, I have to Google for like 5 minutes. You know, I've been whining about this keyboard before. If you can recall. Oh, hang on. And since it's a laptop keyboard that's been designed, and it uses like some of the keys are really big and some of the keys are really, really small, and it's so easy to just hit the wrong one.
Oh.
I think it might be. Yeah, that was it. I found it.
Oh, okay. So on the line with B2, you want to say A0 instead of B0.
Yeah.
And we want to repeat that for A1 and A2.
So A1 equals A0.
Yes.
Slash A0.
Yeah. Except that you want to start the line with A1, not A0. Right.
There you go.
So now the coefficients are normalized. Let's go back to the formula and make sense of the next part. So we see a bunch of x's. We see x of n minus 1, and x of n minus 2. Do you know what the x's are?
They are stored samples.
They are. X of n is the sample that just came in, and being like, you can think of this as time. Yeah, you can think of this as a timeline. So x of n is the sample we are looking at, the sample that just came in. X of n minus 1 is the previous sample, and x of n minus 2 is the previous to previous sample.
Yep.
But in JS Effects, we don't have a way of saying, give me the previous sample. Well, not directly anyway. We do have a way of saying, give me the current sample, so we can get at x of n, but we cannot get x of n minus 1 and x of n minus 2 directly. We need to do a bit of work to get them. So do you remember how to do this?
SPL equals 0 equals, you need to store them, and then previous sample, previous sample.
Yeah. So write a sketch of what you think should be written, and then we'll work on top of that.
That's not going to help me much. Sample. And then prev. So equals prev.
Okay. Is that all?
I usually check this. No, something's missing, right?
Well, let's start with...
I usually copy something when I do this. I usually copy some old code.
Fair enough, but let's try and make sense of this from first principles, because it has been a while. So, to begin with, think about where this code is. It's in the slider section.
It should be in sample section, right?
Correct. Now, let's work step by step what's going to happen. So, suppose that the first sample just came in. There were no previous samples. Can you walk me through what's going to happen?
And also I need to use SPL sum in this case, right?
Well, it depends on what we are filtering. The X in that formula is the signal that we are filtering. Do you want to filter the left channel? Do you want to filter both channels independently? Or do you want to filter the sum of both channels?
The sum of them.
Okay, so yeah, you're right. It should be SPL sum. Okay, so walk me through what's going to happen when the code starts executing and the first sample just came in.
SPL sum. Isn't that the... So it's gonna sum the first of all, it's gonna sum left and right in SPL sum, and
on the line where the cursor is, there is SPL sum equals prev sample. So the variable SPL sum is going to receive a new value. It's going to be assigned to. And that value is prev sample. So far, we are on the first sample. We just started running this code. What is the value of prev sample?
The last code, the last sample,
Well, not really, because it's the first sample. There are no previous samples. So in JSFX, when a variable is used for the first time, its value is 0. And unless you tell JSFX otherwise, which we didn't, it's going to be 0, right? So what we're doing is setting SPL sum to 0. Is this what you want to do?
My brain is fried. We're having a massive heat wave here.
Oh, really? Wow.
Yeah, it's freaking hot, and it's been freaking hot for a week. So
what is freaking hot for you? I suppose it's gonna be relatively mild for most people.
Yeah, it's relatively mild by Southern European standard, but we're having 28 to 30 degrees.
Oh.
But since Sweden is built for cold winters, and whenever it gets really warm, it gets like freaking hot. So it's usually like our houses are built for like cold climates. So anything indoors so everything gets like really hot, or really sort of it gets stupid hot.
I see.
Yeah,
It's hotter than here, I can tell you that.
Yeah, I heard reports of the rest of the Europe being colder, or sort of milder. So
Yeah, we are getting like 21, I guess.
oh, lucky you.
And it is true what you're saying. The temperature of the room affects our performance in terms of cognitive abilities.
Oh yeah.
It's crazy.
Am I writing this? Am I right in this thinking that this should be the previous? No, this is the current sample.
Well, prev sample is a variable that we have not defined. We never said prev sample equals something, right? Nowhere in the code, not just the sample section, but not anywhere in the code, we are saying prev sample equals.
It needs to be the other way around. So previous sample equals SPL sum.
Okay, go ahead and do that. Okay, so now what's going to happen? When the first sample comes in, there will be the sum into mono line. We established that that is correct. And then we get to prev sample equals SPL sum. What's going to happen then?
It's going to store that sample.
It's going to store that sample. So let's go to the next line, because that's the correct behavior, right? We are storing prev sample. The next time we go around the loop, prev sample will be the previous sample. Great. So on the next line, you are saying that prev sample is equal to prev sample. What's going to happen there?
It's going to do the same thing. It's going to store it. So this is going to be the current sample as it's run through it. A couple. Oh shit! Crap. Current sample, previous sample, and then previous sample.
Yes, but think about what's going to happen. Like, let's say that SPL, it's the first sample. The left channel is 0.25 and the right channel is 0.5. So SPL sum is 0.75, right? Yep. Prev sample is equal to 0.75. That makes sense, because the next time we go around, that's going to be our previous sample. But the previous to previous sample is also going to be 0.75, because you just assign to prev sample and then you use it on the next line, right? So you are not storing the previous to previous sample in the prev sample variable. Do you see what I mean?
Nope.
Okay, so...
Sorry.
For what?
I've checked this so many times when you're doing this with Aria in one of the streams, but I just copy the code.
Well, as long as you understand what the code is doing, it's fine to copy, but in many cases it is important to understand what's going on, right?
Yeah, absolutely.
Of course. Okay, so the issue that we have here is that prev sample, you wanted that to be the previous to previous sample, but you are assigning the previous sample to it. So it's not the previous to previous, it's not x of n minus 2, it's actually x of n minus 1.
Okay.
And the solution for that, can you imagine what it is? The solution for the other problem we had was to reorder the variable names. Can you imagine what the solution for this problem is going to be?
Reorder them again?
It's actually to reorder the lines. If you reorder the two lines, then prev sample is going to receive the current previous sample, which is going to be the next previous to previous sample. I know that the phrasing is kind of weird, but that's what's happening.
That's it?
Yeah. Yeah, that's it.
Okay.
So now we covered the axes, and we named them differently, so we need to keep track of the names. SPL sum is x of n.
I can rename them.
It's up to you, whatever you want to do. As long as we know what we are doing, it's fine.
Yeah. Let's keep them that way.
Okay then. Sometimes I like to name my variables according to the paper, cookbook, or whatever I'm implementing. Sometimes I find that very confusing. So sometimes I rename everything because it makes more sense. I mean, prev sample is already a better name than x of n minus 1 or whatever, but it is longer. So yeah, it's a trade-off.
But then again, the sort of what I like about this is a convention as well for an array. So an access and information from an array, and to me that makes more sense. So.
Well, in that case, it seems like you want to rename the variables, and if
no.
Okay.
It's since it's not using arrays in the first place. So JUCE is doing that, right?
Well, JUCE has a different model of how the samples are presented to you as the developer of the plugin. In JS Effects, you get access to the samples one at a time. And in JUCE, you get access to the samples one block at a time. And that means that these samples are presented to you as like an array or a vector, or however you want to think about this. Different languages have different names. But in C++, it is an array, I guess. Yeah. It is.
That's the sample block size?
Oh, in JUCE, it's not actually an array. In JUCE, it's like a whole object. But in iPlug, it is presented to you as an honest-to-goodness array. Anyway, yes, it is. That's the block size. That when you set in Reaper the block size, you're setting the size of the block that the plugin is going to receive when it's implemented in JUCE. In fact, under the hood, JS Effects is also doing that, but it's also processing the samples in blocks. But as a convenience, we are given the sample section because in most situations, what you want to do when you receive a block of samples is to loop over them. So JS Effects has this construct of the sample section that is a convenience for you. It's kind of implementing the loop for you. Okay, moving on. Now we have the axes in the formula. And let's go to the formula again to see what else we are missing. We have the A's, B's, and X's. We are missing the Y's. So the definition of Y is this very formula. So perhaps you can copy the formula and paste in JS Effects, and then we start renaming stuff.
So what does Y represent?
Y is the output of the filter. X is the signal that you are inputting into the filter, and Y is the signal that you're getting out of the filter. It's the result, the filtered signal. So let's start converting this formula into JS Effects. Instead of Y of n, you may use Y underscore n, or you may use output, or I don't know, filtered SPL sum. You come up with a variable name.
Output sounds fine.
Okay, that is equal to, and in the formula we see B0 divided by A0, but we have already divided B0 by A0 in the slider section, so we may just use B0 as it is. B0 times, and then how did we call X of n?
That's the SPL sum.
Correct.
And God, my brain is so fried. What's that character called?
Semicolon?
Semicolon. Thank you.
But no, we are not done yet. Semicolon is for when we are done, and we still have a lot of formula to implement. So plus... Yeah, continue.
B0 divided by A1. A0 times, but that's defined already. So just B0.
Type it out.
Times S prev sample.
Continue.
Plus no B1. This is supposed to say B1, right?
Continue.
Times pre. Where's Photos, by the way?
Where is Photos? That's a good question.
Don't try to change topic.
Yeah, you keep going while I try to find my phone and see if he wrote anything.
Plus B2X and then A1 times can you find anything?
You're doing well, continue.
Yeah, I need to store variables for previous outputs as well.
You are correct. For the time being, pretend that you already have these variables and just come up with a name for them, maybe prev output or prev output, however you want to call it. Just come up with names for them, pretend that they exist, and we'll figure them out later.
Oh. Output. That should be it.
That looks pretty good, actually. That looks pretty good. The only thing that I see still missing is the variables prev output and prev output, which we have not defined. But in general, what we're following is kind of it was a bottom-up approach to like do line by line. And just for these two variables, we're kind of doing a top-down approach, which is also useful. Which is to sometimes you just know that you need something, you pretend that it exists, you use it, and then you figure out how to do it. It's a common technique actually when like you know you need an auxiliary function, like you're writing a formula and you need a sine hyperbolic, just pretend that it exists and write out the formula, and then you go and find out how to define it. Anyway, so now we need to define prev output and prev output. How would you go about this, given the experience of having defined prev sample and prev sample?
I'm thinking, do I need to define them before the formula or after the formula?
That's a good question. In fact, there is a mistake. Now that I'm looking at it again, there is a mistake in our definitions of prev sample and prev sample.
I need to do them before the formula. No, the formula is supposed to go before.
I think that the formula is in a good place. Hang on. Is this true? Am I confident about what I'm about to say? Because I don't want to confuse you even more. Yeah.
Was phase rotator? No, that's a different thing. We call it phase plant or something, didn't we?
Yeah, okay. I am confident about what I'm gonna say. The only mistake we made is that SPL sum should be computed after the storing sample for processing, blah, blah, blah. but before the formula. So right where your cursor is, that's the right place. Yes, that way. No, you had it right.
Oh.
Control Z. There, that. So now we are doing the shuffling of the previous samples.
Yeah. Oh, it makes sense in my head now. Yeah.
Okay.
Storing the samples that way. You run through the code and then it stores, and then it next time it runs through the code. Then it looks at the previous one. Oh yeah, it makes much more sense now. Yeah.
I'm still just juggling this in my head to make absolutely sure that this is gonna work, because sometimes it's difficult to tell with the result of the plugin. It's better to just think through how things are gonna run, and I'm confident that this is right. Let's not cheat. You're looking at code from some other plugin and trying to compare, but let's not do that. Let's try and see if we can get this right.
Sure.
So without looking at someone else's code, but kind of with this idea of how we are manipulating prev sample and prev sample, try and implement prev output and prev output.
That has to go, since the calculation is done here. So they have to go after the oh well, I'll just do it. You should stop me if I'm incorrect.
You go ahead and do it.
Good. Here's a weird thing. If I've defined a variable previously, isn't that supposed to show up as a suggestion?
Maybe it only auto-completes variables that have already been assigned to. Because that variable has been used but not assigned to.
Okay. Compiles, okay, so.
Always a good sign.
Am I correct in this?
Yeah, the only thing is, again, the output should be computed as the last line. It's the same mistake that I made when I was guiding you through the manipulation of the SPL sums.
An output equals what?
I mean, that line that is really long, output equals B0 times SPL sum and blah, blah, that whole thing needs to appear as the last line. And that should do it. Okay, yeah, I think that everything that is on the screen seems to be correct. But note that we have computed the output, but we haven't really produced the output for JS effects to pick it up. To do that, we need to assign something to SPL0 and SPL1. And that's when you kick in, actually, because I don't really fully understand what you want to do. You said that you wanted to add and subtract stuff. So what is it exactly that you want to do?
I'm thinking there should be a phase, since it's an all pass, that we should see some results on the frequency analyzer.
We should, but first we need to assign something to SPL0 and SPL1, because the way that JS Effects works is SPL0 is a special variable representing the left side of the sample, or the frame, to be more specific, the left side, the left channel of the sample that just came in. And when you use it, like we are using it on the line that reads SPL sum equals SPL 0, we are using that to read the sample that just came in. Perfect. But we also need to produce a sample on the way out. If we don't, it's not going to change the signal in any way. So we must have a line that reads SPL 0 equals something. And that is going to produce the output. So maybe it is going to be SPL 0 equals output. I'm not sure. You said that you wanted on the left channel to be the sum and you wanted the right channel to be the difference or something. I'm not sure.
But let's just check. So that should check if this all pass is working at all, right?
Well, the way that you say this, you are signing SPL sum, so it's just going to be mono, right?
Yeah.
Do you want this to be the output, maybe?
Just for checking, so that the filter actually works.
But we are note that you are not producing the output of the filter. You're producing SPL sum.
Yeah, but the SPL sum is the filter.
No, output is the result of the filter. Hence the name.
That's the name. Frequency shift.
And a magnitude increase of 6
yes,
dB.
But yeah, exactly. And it's moving as well, and we can change the
You got this.
This is awesome. Delete this. What we need to do now is so I'll sort of write it out. Subtract signal from out. And then what's left, i.e. the phase. Is supposed to be added and subtract either channel. So
while you're writing this, let me say hello to people here on the chat. Hey, Nautilus1. Hey, John, Toucan Studios, and Dale. And Fotis is here saying that he's not joining us today. Oh, that's too bad. We're going to miss you.
He was on the chat earlier on Discord, and
yeah.
Anyways,
you know how these things go.
Yeah, absolutely. Hope you're doing fine, Fotis, and Tail, and John, and everyone else. Yeah. So outpost minus SPL sum, right? Subtract the original signal from.
Do you want to subtract the original signal, or do you want to subtract the sum, which is the mono version of the signal?
Yeah, the mono version.
Okay.
SPL 0 equals. and then I need to add that, and that amount needs to be adjusted. Sub. So output stop me if you think this is way off. This should be hang on a bit. Output.
You're doing well.
Be like this, right?
Continue.
And I think or I could create a variable sort of output minus SPL sum times amount, and then
Oh, I see what you mean.
yeah, but
Yeah,
this should do it.
Yeah, let's worry about getting it right first.
That's weird. I should have some more manageable numbers.
Or perhaps
yeah,
we could use the logarithm sliders. That's what they're for, and I have never used them. Do you want to try them out?
Sure. I don't think it should be above 10 or sort of too low at any rate, but that's for some later testing. I'm going to need to do some audio testing or sort of testing on actual tracks for this. Yeah, sure. The log. So
that's kind of a tangent, just to have fun, because I never played with it.
Yeah, sure.
Let's go to the JS effects documentation and look at how the syntax looks like.
Oh man, right.
Yeah, I don't think it's in that section of the manual. I think it's like back to main JS effects page, reference page, the link right below the header. Back to main JS effects reference page. Above the title of the page, there is a small link that reads back to main JS effects reference page.
Oh.
There
you go.
Yeah. And search for slider in this page. I think you will find it. Yes.
Slider.
And then the part explaining log is right by your cursor at this point.
So it's it's within the brackets. The colon.
And it's funny that the IGE thinks that that's a syntax error. They didn't update the IGE. Whatever. If you save that and you play with the slider, does it behave more exponentially or logarithmically? It does.
It does, yes. Indeed it does.
Nice, nice, nice.
Still too high, but I can check that later. We're done. I think this is it.
Is this what you wanted? Because this is not just an all-pass filter. It's not just changing the phase. It is changing the magnitude.
Well, it should do that because you're adding and subtracting to the left and the right channel.
Okay.
This is I could be wrong on this, but this is in sort of an idea that I had for.
And it seems reasonable to me. I was watching the Dan Morrow video about the Kirchhoff EQ or whatever it's called.
Yeah.
And he showed these kinds of EQ moves to try and do some stereo separation, where you have like narrow peaks on the left channel and narrow, I guess, valleys on the corresponding places in the right channel.
Cone filtering, I guess.
Yeah. All right then. So that is that then.
Yes.
Good stuff. Now for bonus points, try to decramp the filter.
Decramp the filter. Oh, that's for another day.
It's not that hard, really. It's just different formulas for computing the coefficients. You don't even have to change anything about the slider, the sample section of the code.
Okay, sure.
Yeah.
My mind was like, I'm thinking the Bertram, it produces this spike. What's it called? That one. It doesn't produce noise. So I'm thinking, will it look different if it produced noise? So if I checked it on goniometer. Maybe. Goniometer, sorry, Fotis. White noise.
You should see, you should see it changing.
Goniometer. And F off, please.
It changes, yeah.
Yeah. So
it gets wider because it is adding difference to the left and right channels. Not only a phase difference, but also a magnitude difference. So
yeah. Oh, it's definitely widening. And it should sum perfectly, and that was sort of the point. I'm more thinking, why is it skewed?
Probably because the shape of the boost was not the same as the shape of the touch. So that's probably what's happening.
Do I need sort of a different alt pass for the adding and as opposed to the subtracting? Oh well, I'm going to need to try and see how this sounds.
Okay.
Cool. We literally achieved a lot today. But should I move on with the other one?
Yeah.
Am I taking too much time?
Well, you can have Fotis time.
Thank you, Fotis. Yeah, so this was the one. I posted this on the Discord. I could not get the formula to work. The IIR filter, or the EMA, as I choose to call them, filters to work. I can add and subtract. I can split. So the idea here, I'm going to explain the idea. I want to create a mix bus separator where I have sort of a background track and then a foreground track, i.e. sort of music and vocals separated. And the way to separate them is to process the upper half of the signal differently from the lower half, and then swapping that for the different sort of mixed buses. Do you get it?
Partially.
Partially.
So the plugin is going to have two signal inputs, two stereo inputs.
No, as you need to put the plugin on two different mix buses, and it's going to do the opposite of each other on those two mix buses.
Two folders in Reaper with two instances of the plugin configured in a way that they complement each other.
Yes.
Okay.
So sort of very much like a summing thing, like a Chris Air Windows. He has his consoles that does one thing on one mix bus or tracks, and then for the summing, it does the opposite of that.
It's, as far as I understand, not quite the same. In the console plugins from Air Windows, you put one instance on each folder, let's say, but they are all doing the same thing. They are not doing complementary things. They are all doing the same thing. And then you put an instance of a complementary plugin, which is not the same plugin. It's like the opposite plugin.
Yes.
On the master.
Yes.
And what you are telling me is that you have not a bunch of tracks, you have only two, and you will have two instances of the plugin, but they're going to be the evil twins. They're going to be the different instances of the plugin.
Yes.
So there will not be a master plugin as well, right?
That was the original idea. You could probably use it like on every, put it on whatever channel you prefer, and then have the opposite of it. So it does one thing on a couple of tracks and then does another thing on other tracks as well.
Okay.
But my original idea is to have it just on the buses because it's just simpler.
Okay. Yeah. But you're only going to have one plugin. It's not going to be like Air Windows where you have one kind of plugin on each track and another kind of plugin on the master. You're only
they're going to be the sort of mirror image of the processing on the two different instances. But my idea is to have the choice of, so I call this the foreground and the background. So if you add the plugin, you can sort of pick which one flavor you want.
Okay.
That's sort of a technicality more, but.
Gotcha.
Yeah.
So, what do you want to do to the signal when it is on the foreground?
Yeah. So on the foreground, I want to have an IRR filter that instead of adding the IRR filter, you save the previous sample and you add it by a smaller amount of the previous one.
I know what you're getting at, because an IIR filter is exactly what we implemented in the previous plugin. It was holding on to previous samples and using them, or more importantly, holding on to previous outputs and using them to compute the next output, which means that any output depends on everything that came before it, of course to lesser and lesser degrees, but still it's an infinite impulse response because every output sample depends on all the previous outputs. So that's an IIR filter, but I think what you're mentioning with you multiply by a smaller value and whatnot, you're probably hinting at the fact that you want to have a first order IIR filter.
Yes.
Is that right?
Yes.
Okay. I'm following.
So this is a first order, and it works on fine on new. What the frig happened now? What the? So I have it on the right channel. That's so. It's actually working. It's smoothing the treble. But in order to test this, I've split the signal upper half, lower half, and I'm adding to the upper half and subtracting from the lower half. Hence the square wave going upwards. But whenever I put in this formula, so the formula is working here, but not when I split the signal.
Okay, let's see. I'm trying to spot any obvious issues. Can you go back to the way you wanted it to be with the formula? Okay. Ah, I see. So,
do I need a different variable? Do I need to produce a variable for the upper half so that the upper half works separately from the lower half?
I don't know, there's something weird that you're doing. You're changing the multiplication sign for an equal sign. Why are you doing that?
Oh, this is the standard 6 dB that I think I got it from Justin Johnson.
Ah, okay. So, but what's weird to me is that you are assigning this to SPL0, then assigning this to S00, and then assigning SPL0 equals S00. It doesn't matter because S00 is going to be SPL0. So it shouldn't be a problem. It's just weird that you have that line there. But okay. And then pos is the square root of the wage, and then neg is 1 divided by the wage.
Never mind the square root, is to make it more manageable.
Fair. Okay.
So it's the positive it's adding and the negative is subtracting values.
Well, shouldn't it be then 1 over the square root of the wage?
Maybe that's kind of for adjusting later if it actually works. But sort of making manageable values for this, I don't know. I have no idea what the manageable values for this is going to be. So this is sort of just shooting from the hip. Okay,
so in the output, what is it that you don't like? What is it that you think is wrong?
It's not the IRR core isn't working. Simple as that. It just stops working.
We are affecting the blue signal, aren't we?
Au contraire. The blue signal is the right SPL1, so that's the right one. And if I...
Okay, and the green signal is the one that we are trying to affect.
Yes.
Well, perhaps we are affecting it, but the square root is making the effect very subtle. Could that be the case?
Well, then it should. So then it should look. It should, since I'm using the same variable here. See, it should sort of copy that. It just breaks. Is Tail in the chat? I think this.
He was, yes. Yeah, I guess I am at loss because I'm not even sure I understand what we were supposed to be doing.
I had one sort of idea of let's see, well, if the input is positive, then the anode is being used for.
Well, you said that if Dale was on the chat, and in fact he is saying something. So perhaps that helps. If the input is positive, then the N00 filter is being used. But for negative, N00 isn't updated at all. That seems like a reasonable thing to... and he's saying that seems wrong to me. And that seems like a reasonable comment, because for the filter to work, N00 needs to be updated with the previous samples as they come, or they need to be taken in account. But when you are going below 0, you are not touching the N00 variable at all. So it's just staying high.
Yeah. I got it now. Oh man. So it's.
Is Tail saving the day again?
I think so. It's just the formula is simply going dead. The moment the signal goes below 0, the formula goes dead. Is that it?
Yeah. And importantly, N00 is never going to see those samples.
Yeah.
And because in your test signal it is a square wave, so it goes immediately from 1 to -1. You are going immediately from 1 to something negative, so N00 is never updated. And when it gets updated again, it's seeing a signal at 1.
Yeah,
so
that must be it. Yeah.
What N00 sees is just a straight line.
Yeah, makes perfect sense. I was thinking of doing wave shaping for this, but I was sort of afraid that the 0 crossings would produce a sharp, since it's going to be different wave shaping for the upper half from the lower half. I'm a bit worried that the 0 crossing might produce like anti-alias, sort of aliasing.
If there is any kind of discontinuity at 0, there is a chance that you will get higher harmonics that may alias. But that's sometimes just the nature of the game. You do want... It depends on what you want. I'm not sure what is the flavor that you're going for. But if you want something that adds distortion, that adds upper harmonics, the aliasing is going to be a fact of life, and we have ways of dealing with that, either oversampling, or recently there was a talk in the audio programmer meetup from Geraint Luff about a different technique to do anti-aliasing in wave shapers, worth looking into. It's not that difficult to implement, really, so you may just want to bite the bullet and do something about the aliasing.
Yeah. So the idea that is in my head is the sort of for one bus to have. So in this case, I would for the upper half of the wave signal would be sort of exaggerated via a positive value in the IRR filter, and for the lower half it would be duller. It would be a low pass filtering, and so and doing the mirror effect of that on the other bus. So there would be a separation between the two buses via different processing of the upper and the lower halves of the waveform. That's the idea. It might be the stupidest idea ever. It might be a good idea.
Well, maybe what you can do is just update the N00 variable when it is below 0, when the input signal is below 0. Just update it to something. Not even sure what at this point, because I'm very confused, but at least the filter will behave correctly, I guess.
Yeah, maybe I should run the this is taking too much time, but I should probably do the filtering before I split the signal. So create variables for a processed signal so that the formula works, the IRR formula works, and then split the signal and use it differently.
That sounds reasonable.
Yeah, that's what I'm going to try.
Okay.
Cwits. Or should...
And just like that.
Yeah.
Sorry, I've heard my name. What's happening?
Bo already has homework. He's done for the day. What do you have for us?
So cool. Sorry, I just wasn't paying proper attention. No offense at all. I was trying to...
I'm boring with my IRR filters.
I was trying to run to program my things slightly
Are
forward.
you doing last minute refactoring?
Yeah, kind of. But it's always last minute refactoring. If you want, guys, I can show photo because I've turned off everything already. Sorry, and I don't have proper internet connection for showing video stream, normal video stream. Yeah, how my things looks like.
Sure.
I
Yeah.
can. It is like main screen. I'm trying to move from... I don't know how to explain. I want to make it looks like more regular DAW, like digital audio workstation, and it looks like this right now. I've got some kind of tracks and I can load some items there. As I heard, by the way, the way of Reaper dealing with audio and MIDI items, allowing to put them on the same track, is weirdo, because no other digital audio workstations doing that. Is it right? I don't know.
Reaper is the only DAW I know that has this property where tracks can hold different kinds of media, MIDI or audio. It's the only DAW that I know that allows you to do that. Do you think that that's a good thing or a bad thing?
I'm not sure about that. I really not sure about that because I don't have much to compare. But in the case of writing code, maybe holding things together is slightly easier. Maybe.
Okay.
I'm not sure. No, I'm not sure as well. Because it just looks like you have to write a couple lines less code than if you want to keep the things separate.
And
Like
in your implementation, are the tracks like in Reaper or like in most other major DAWs?
I will try to do it as in Reaper. I'm like pending to do right now, and yeah, they can hold an audio and MIDI tracks and MIDI items in one track. So I'm not sure how I will process them. Yes, at least I can draw image on the screen, like having like this is the same track, no difference. Is you can slightly see there written MIDI and audio. Sorry, the scale of the text not so great. If you remember, guys, previously it was like small rectangles drawn, and I didn't have the tracks, but now I can load some kind of effects on each track and do things. So yeah, things moving on, and I'm happy about that. But sadly, it's happening slow, very slow.
Well, that's a lot of progress. You shouldn't say that. Well, and I'm kind of curious. People who are watching this, say in the chat if you ever used that feature in Reaper, because I do like the fact that I don't have to think in advance which kind of track I'm using, if it's audio or MIDI or even images and video are special tracks in other DAWs. And in Reaper, I can just throw anything anywhere. But in practice, I have never had a project, I don't think, probably didn't, never had a project in which I actually used this, in which I had media items that were of different types in one track. I either have a bunch of MIDI items in the track and I have some MIDI synthesizers and whatnot, or I am processing audio, I'm recording stuff with audio. I don't think I ever did both in one track. I do find it nice, conceptually it's cleaner, but I don't think it's actually like a deal breaker.
Yeah, but when you have to do things like on the fly, you don't have to bother yourself of thinking what kind of track you need for this or for that. And
no, yeah, I absolutely love that. I think it's conceptually simpler and it is nicer in every way. It's just not something that is like I ever use.
yeah, the thing. Maybe you just don't think about it because Reaper doesn't bother people about it. But yeah, some kind of short update again. I don't know what to say. And what to tell. There is nothing much to tell, and it will be fun when it will be ready. I assume.
How do you load this? Do you have just the user interface, or do you actually have a way of loading audio and MIDI, or do you have a way of performing MIDI?
Sorry.
How do you? Is this a mock-up? Or is this actually a usable interface? Can you drop audios, media items in the timeline and play it?
As in my previous version, I have here same browser for files. Yeah. Okay. Not actually same. Slightly. How it is called in English? Reorganized? No. Refactored.
Okay.
And yeah, it can load actual files on the separate track or on the one track, and I didn't get to till moving those files amongst the track, but I will get there. Hope soon.
Okay.
But yeah, this is not just fake white. Rectangles, but I don't know how this shape is called in English. Yeah, white rectangles. But this is actual files that I can load in my.
All right. For next time, I want to see a demonstration of all this.
I hope that till the next time I will have better internet. So.
Fair enough.
When it be ready, I will show you guys everything.
Looking forward to it.
Cool.
All right.
So, yeah.
Oh, what do you have, Leandro?
Yeah.
How about we write some C++?
Yeah, sure.
Yeah.
Did I boot up ChatGPT?
Oh, you want to do that again? Okay, let's do that. I think that we are doing problem 5 today. Let's see. Yes, that's problem 5. Let's dive in. The smallest multiple. 2520, and I love that they used they used LaTeX to print the number, so it's actually probably an image or something. It's definitely not selectable. It's in a different font. Is it an image? Yes, it's MathJax. It's not an image exactly, but it is MathJax. I love how they did that for a number instead of a formula. Anyway, is the smallest number that can be divided by each of the numbers from 1 to 10 without any reminder. What is the smallest positive that is evenly divisible with no reminder by all the numbers from 1 to 20? Okay. I can see 2 ways of going about this. The first is to multiply all the numbers between 1 and 10, and then try to remove factors from that number to get the smallest.
Can you show your screen
Oh,
on the
yeah,
Skype?
yeah.
At least I don't know what's happening on the stream, but
Yeah, on the stream people see it, but you were not seeing it. Thanks for
okay,
reminding
thank
me.
you.
Right, so the problem is to find the smallest number that can be divided by all the numbers from 1 to 20. And I can see two ways of going about this. I can either try to multiply all the numbers between 1 and 10 or 1 and 20 and then try to simplify, try to remove some factors that are redundant. Or I can do what I guess is the brute force approach. I can go starting at, let's say 11, for instance, in this case. Starting from 11, I can go 11, 12, 13, and so on, and I can test. Is this divisible by 1 to 10? Is this divisible by 1 to 10? Is this one divisible by 1 to 10? And until I get to the number that is, and then I output that. I think I'm going to go with approach number 2 because it seems simpler to conceptualize. It's brute force. And I always like to start with brute force and resort to something more clever if necessary. So I'm going to start with this. And I think that at this point, the message that we got on Skype was Bo sending the answer. Is that right, Bo?
It's ChatGPT's answer. I don't know if it's a correct one. You never know with ChatGPT.
Yeah, okay. Well, we are humans, and we are going to do the human version. So I don't think we will need strings in this program.
Oh my god.
What?
I've tried that ChatGPT answer on the online GDB compiler.
Oh,
Yeah?
no spoilers! No spoilers!
No, just okay. I want to check if the answer there will be the same as you will have.
Okay, so I'm going to come up with candidates. And I'm going to have one of those weird loops where there is no stop condition. So this in the middle, I just skip this clause, which is something that you can do. And I am going to check for yeah, is this the divisor? I don't remember. Division operands. Yes, it is the divisor. Okay. And we are going from 1 to 10. I'm going to try and come up with this answer first to check that my program is correct. From 1 to 10. And I'm going to optimize something that is silly. Dividing by 1 is always going to have a reminder of 0. So I'm going to put 2 here instead. But it should be just one division per number. It shouldn't make a whole lot of difference in terms of performance. Anyhow, if the remainder of the division between the candidate and the divisor is equal to 0, then it is evenly divisible. Okay, so I'm gonna do the following. I'll have a boolean that is divisible, and it's gonna start with true. If I get a division that is not with a reminder of 0, I'm gonna do two things. I'm gonna say the divisible is false, and I'm gonna break out of this loop because I already have my answer, no point in keep trying. Then, if by the end of all that, if it's still true that the thing is divisible, then I am gonna do two things. I'm gonna output the candidate, and I am going to return 0 or break out of this loop. guess I'm gonna break out of this loop. So it's gonna stop searching. In essence, this break replaces this stop condition, but in a less structured way. Okay, that sounds reasonable to me. Let's see if it works. And I should rename this file. I am making 5 humans and I want to run 5 humans. Okay, we got as an output 2520 and we got it in reasonable time. Now let's try and do 20 instead. And it was very quick. Is it correct though? The way that I was checking this was kind of giving away the answer because I already have an account in Project Euler and I'm signed in here. And yeah, completed when dinosaurs roamed the earth. Yes, I did these problems a long time ago. But anyway, we got the answer right. Yay for us.
Cool. Well, congratulations.
Now let's see what the ChatGPT thing did.
I think that I have like strong feeling that there should be more elegant way to do this instead of brute forcing.
Oh, there is. You can... I think that the smart way of going about this is to find all the greatest common denominators between all the numbers that you're interested in this case, the numbers between 1 and 20. Find all the greatest common divisors and then multiply all of them together. I think that that's the smart way of doing this. But the brute force approach is always a good one because it's verifiably correct easily, like in this case. But let's see if ChatGPT got the more clever algorithm. Let's see what it has for us. Function to check if a number is divisible by all numbers from 1 to 20. Is divisible. It gets a number, it loops over, and that loop is very similar to the one we wrote. And if the number is not divisible by 0, then it returns. Yeah, it extracted a function, but in principle, what it's doing is equivalent to what we did here with this and the divisible variable and this break, which this break is replacing this return. And you can see a tendency from the exercise from last meeting and this one, that I tend to write stuff in line while ChatGPT tends to extract functions. That's an interesting observation. But then again, ChatGPT doesn't tend to extract functions. ChatGPT has been trained with code that tends to extract functions. Moving on. So this is following a brute force approach because it has a while true loop. I wrote it as a for loop, but this line and this line and this line, if you combine all three, you end up with this. I would say that this is better, but anyway. Oh, and it started with 1, which is also silly, because for sure the numbers between 1 and 20 are not going to be the answer. But anyway, if it is divisible, then break out of the loop and then produce some output. So it seems like this is gonna work. Let's compile and see. And I find it interesting that ChatGPT did not try to be smart. It went to brute force. And it got the answer right. I am interested in something though. Is this a human bias? But I feel like mine was ever so slightly faster.
Way faster.
That's weird because it's now too slow even compared to the previous run. But yeah, it seems like mine is faster, and the only significant difference is that I didn't extract a function, right? What else did I do that is different? Well, I optimized this. I'm not checking the number 1, because that's silly. And that's inside another loop, so it's kind of a hot path in the code.
Now, what's the deal breaker? That the ChatGPT version starts from the 1 and you start from 11. Like
Come on, that's just 10 checks. It does not account for a 2x difference. Mine is, or 1.5 difference, let's say. Mine took 1 second, and while ChatGPT took 1.5 seconds, let's say. So checking for 10 numbers cannot account for a 50% difference in performance.
But still, you're checking half less numbers, no?
No, I just skipped 10 numbers. I started in 11 while it started in 1. And I am not checking the number 1.
Yeah.
So I'm doing one less comparison. But one less comparison in 20 comparisons should be a difference of 5%, not 50.
Yeah, you're right. You're right.
Could Skype and the internet connection be hogging resources?
Well, let's time ChatGPT again. 1.6. Yeah, but these are different runs, okay?
Yeah.
These are different numbers. I'm not cheating. No, this is consistent. ChatGPT's version is like 60% slower than mine. I'm gonna run mine over and over just to get a feel for it. Yeah, mine is faster. Now that is something that I want to know. Why is mine faster? Is it because I didn't extract the function?
Yeah, maybe because of extracting function.
Ah, come on. I don't know why I could just copy and paste. I don't know why I'm typing. And what I want is to do, I guess this goes away, but I'm commenting out because I want to revert this later. Well, I'm gonna Control Z, so it's fine. Then,
no, wait, get it back.
Why?
Paste in the function, not ChatGPT's version, but your loop, that second for loop.
What about it?
No, just use it instead of ChatGPT's version.
You mean just take this and copy it up? Okay, as you wish. And then the candidate here is the number. And here we return false. And here we return true. Just like that. And then divisible becomes is divisible by candidate. And then we make and time. Make humans. Okay, and then let's time. Okay, it is slightly slower than it used to be, but not by that much. The only semantic difference now is this. What the hell?
I
didn't make. That's not fair. I didn't make. Okay, let's try again.
As well as ChatGPT using while function.
Oh, there you go. That accounts for it. Now we are getting that result. So extracting a function made a small but noticeable difference, and checking the number 1 made a more significant difference. I am surprised. I thought it was going to be much less of a difference to check one extra number. But I guess the lesson, what we learned today, is that this operator is expensive. Because doing one more of it makes the code a lot slower. And even extracting functions can be expensive. So the lesson is, if you are not reusing the function, you might as well just inline it, because the compiler is not going to be smart to do that for you. Unless I should maybe in my make file set some clang flags to optimize the code, and then it would be inlined, and then we wouldn't see this difference. Maybe. But, and this is my version again, but there you go. Take that, ChatGPT. I beat you.
Oh,
That was a nice experience. I learned something.
Yeah, cool.
good. Excellent.
All right. So with that, are we ready to wrap up?
Yeah, sure. Absolutely. I'm happy.
All right then. So thank you, Cwits and Bo, for joining me on this meeting. And
Thank you for the opportunity to have this meeting.
Thanks for helping out with my stupid code. I just realized something. Never mind.
what?
I think that processing the signal and then splitting it, that's going to produce even sharper zero crossing anomalies. But I could probably do a blend of some sort.
Yeah,
Sort of
and
mix it
anomalies at
together.
zero crossings are like relatively common in amplifiers that do.
Class B amplifier.
Yeah, that. I was trying to remember if it was class A or class B. So yeah, so it's something.
But I could probably maybe mix it. I'll have to think about it. Maybe I should just try it with the wave shapers and see if it makes a difference. If you see what it actually sounds like.
Or you
See how the
can change the marketing to say that it has some analog feel to it.
Absolutely. Absolutely.
Okay.
So sounds like a good approach.
Yeah, that's how you do it.
Yeah.
And Tail is saying, are you compiling with optimizations? Because without them, the function call will have overhead. Yeah, that's what I mentioned at the end. I think that if I put some compiler flag that that optimizes more aggressively, then the compiler would notice that the function is used in one place and it would inline the function. But in this, the way that I'm compiling now is without any special flags. It's just this. And it's probably doing the naive thing, which is to push to the stack, jump to the function definition, and pop from the stack. And I guess there is something to be said about the principle behind my approach, which is, yes, it is faster, but there is a philosophical thing here, which is I am avoiding premature abstractions. I am only checking this in one place. So what's the point of extracting this? Giving it a name could be a good answer for this question, because by giving it a name, perhaps your code is more readable. You can even pretend that you know what this does and then read the code like this. But in some cases, coming up with names for stuff is confusing and you're not really sure what the thing is yet, and you have to experiment, and then you got the wrong name, or you got the wrong number of parameters, or the wrong return value. So, and on the upside, if you have this and a second chance of using it arises, then you will have an abstraction already. And while in my case, you may not notice that you're repeating yourself. But if I was to do this again, to do this extraction, I would probably, for instance, not hard code the number 20 here. It would have a generic is divisible numerator denominator, something like that, because this seems like a bad abstraction. So then again, I think I beat the machine in terms of readability, because I think that this function is not really reusable all that much, and it's definitely not reused. So there is something deeper about this code that I find interesting. And it seems like ChatGPT tends to prematurely extract functions, given the outputs of problem number 4. Anyhow, let's say goodbye. So thank you, Not Was One Tail, John, and Fotis for joining on the chat. I appreciate you being here, and I see you next time. Bye, everyone.
All right.
Thank
Bye.
you,
Take
guys.
care, everyone. Bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.